Imagine this as a kind of oil well of the future. This as a kind of oil farm, where the humble microalgae is grown in such vast amounts that it reduces our dependence on fossil fuels.
We've moved it from basically a 20-gallon system to a 450-gallon system, and now the next step will be, can we put this offshore somewhere with not 4 bioreactors, but 400 bioreactors?
Jonathan Trent is the NASA scientist behind the Omega project. Omega for offshore membrane enclosures for growing algae, whose goal it is to produce a sustainable, renewable, carbon-neutral fuel. Biodiesel from algae farmed in plastic containers offshore. After 2 years, $10 million from NASA and $800,000 from the state, Trent and his team think they've found a way, using wastewater as fertilizer. A San Francisco PUC water treatment plant loaned NASA some tanks and wastewater to experiment.
We have flue gas, which has a gas that's rich in CO2 that we can feed to the algae. And we have salt water in these tanks to test our ideas of keeping algae afloat and test the idea that we might be able to kill algae if they escape in seawater.
It's no accident Trent comes from NASA's Life Support Division, where they figure out ways to keep astronauts in space for a long time.
How you can recover waste for real long-duration spaceflight, you can't just take a lot of stuff with you. You have to recycle things, and so there are scientists working on that problem right now. How do you recycle waste and turn it back into food and oxygen and things that the astronauts need for their trips?
The next step is for another team of scientists and engineers to take over where Omega leaves off and figure out if making big enough offshore algae farms, like in this NASA animation, is truly possible. Heather Ishimaru, ABC 7 News.